today's video, we are going to cover similar figures. Our learning targets for today are I can identify similar figures and I can describe a similarity transformation between two similar figures. Dilations do not preserve congruence, so dilations are not rigid motions. A similarity transformation is a dilation or sequence of dilations and rigid motions. So when I make a dilation, that will produce a similar figure. So my image is a similar figure compared to my pre-image. So two figures are similar figures when one can be obtained from the other by a similarity transformation, so a dilation. Similar figures have the same shape, but not necessarily the same size. The tilde sign means is similar to. So if I want to say that triangle ABC is similar to triangle DEF, I would use my tilde sign. Now, similar again means that all three of my angles are congruent. So angle A would be congruent to angle D because they both have three arcs. Angle B would be congruent to angle E because they have one arc. And angle C would be congruent to angle F because they both have two arcs. But the side lengths are in proportion to one another. So for instance, let's say side length AB is 4 and side length DE is 8. That means I multiplied by 2 to get from 4 to 8. So it's a dilation by a scale factor of 2. So if BC is 5, then side EF would have to be 10. And side AC, let's say that's 6, then side DF would have to be 12. Because in order for them to be proportional, I would have to have 4 over 8 is equal to 5 over 10, which is equal to 6 over 12. Because all those simplify to 1 over 2. So if my side lengths don't simplify to be proportional, then I won't have similar figures. So again, my side lengths are in proportion. So for my two figures, I'd have AB over DE is equal to BC over EF, which is equal to AC over DF. And then all my angles are congruent to the corresponding angle. So angle A is congruent to angle D, angle B congruent to angle E, and angle C congruent to angle F. Now looking at a few examples, I want to determine whether the triangles are similar. So my first example, I want to determine whether triangle ABC and triangle JKL are similar. So what I'll want to do is I'll want to look at my coordinates. If all of my coordinates are in proportion to one another, then they are similar figures. So if I look at C, that coordinate is 3, 0, and L is 6, 0. So notice that I just multiply by 2 to get my coordinate of L. B is 3, 3, and K is 6, 6. Again, notice that I multiply by 2 to get both coordinates. A's coordinates are 0, 3, and J's coordinates are 0, 6. So again, I multiply by 2. So ABC and JKL are similar triangles. So this is yes, because their sides would be in proportion based off their coordinates. Now, if I want to look at triangle MNP and triangle XYZ, again, I can look at my coordinates. I can also notice that side NP has a slant where side YZ doesn't. So these are probably not going to be similar triangles. However, if I look at my coordinates, let's start with Z first. Z is 2, 3. Well, P is 6, 8. To get from 2 to 6, I'd multiply by 3. So from 3 to 8, that's not multiplying by 3. So these would not be similar triangles because P's coordinates would have to be here at 6, 9. They're not there. Therefore, these would not be similar triangles. Looking at example 2, I want to describe similarity transformations. So my red figure is similar to the blue figure. Describe a similarity transformation between the figures. Notice that my red figure is bigger than my blue figure, so I know that it's a dilation of less than 1. Now if I look at two coordinates that are matching, I can figure out what that scale factor is. So if I look at this coordinate here and this coordinate here, because they're both matching, the red figure is 4, -2, and the blue figure is 2, 1. In order to get from 4 to 2, I'd divide by 2, and -2 to 1, I'd also divide by 2. So the scale factor is 1/2. So the first transformation that I would make is a dilation with a scale figure of 1/2. Now I want to figure out if it's a rotation, a translation, or a reflection. I can rule out translation because the shape is not in the same orientation. I can rule out rotations because notice the top point here is pointing down. If I were to rotate it 90 degrees, it would be pointing to the right, like so. My two figures do not look the same when I move my blue figure back to its original shape. So I can rule out rotation. Therefore, this has to be a reflection over the x-axis. So if I reflect it over the x-axis, notice if I flip it up and down, it's in the same orientation as my original blue figure. Then if I shrink it by 1/2, it would go to the blue figure. So a similarity transformation, dilate by a scale factor of 1/2, then reflect over the x-axis. Looking at two more examples of this, again, the red figure is similar to the blue figure. Describe a similarity transformation between the figures. So my first example, notice that the red figure is smaller than the blue figure, so it's a dilation greater than 1. If I look, I have a coordinate here of 1, 1. And then on the blue figure, I have a coordinate of 2, 2. So I'd multiply by a scale factor of 2 in order to get my red figure to be the same size as my blue figure. Then I can rule out translations because it would not be in the same orientation. I can make a rotation, and that would be in the same orientation. Or, or I can even make a reflection over the y-axis. So if I were to flip this over the y-axis, it would be in the same positioning and orientation. So I can make a dilation by a scale factor of 2. Then I could either do a rotation or I could do a reflection. Since my coordinates don't have labels, I can do either one. Now, if my coordinates had labels, I'd have to use the transformation that matches up my coordinates. So a dilation by a scale factor of 2, then a reflection over the y-axis would work. Again, I could change that reflection over the y-axis to a rotation of 90 degrees counterclockwise. Looking at my last example, the red triangle is similar to the blue triangle. Describe a similarity transformation between the figures. So my red figure is smaller, so that means it's going to be a dilation greater than 1. And then my orientation currently is the same, so it's going to be a translation. So if I translate it left 5 and then down 4, I would have it looking like this. That's in the same orientation now as my blue figure. Now I can list my coordinates. Again, if I look at this coordinate and this coordinate, I'd have 1, 0 and 2, 0. Going from 1 to 2, I'd multiply by 2. So this is a scale factor of 2. So I will translate left 5, down 4, then dilate by a scale factor of 2. In today's lesson, we learned similar figures have the same shape but not the same size. Side lengths will be proportional and angle measures will be congruent. That's a wrap on today's video. We'll see you in the next one.